Good morning to one and all. Myself, Dr. J. Namrata Manohar, is glad to be back with the second episode on embedded systems. The title of the episode is Embedded Systems Programming Strategic Approach. In my previous episode, we had discussed about the hardware aspects of embedded systems. In this episode, we will be studying the software rather the programming concepts of embedded systems. As a first example, we'll be studying about the 16-bit 8086 microprocessor and 8051 microcontroller, which are in wide use in several applications. The approach of studying here can be applied to any of the various types of microprocessor and microcontrollers, only that you will have to refer the related manuals of the respective chip developers and manufacturers. Most manuals provided by the chip developers will be freely downloadable. Before we begin, I would like to inform about the videos I had made so far, so they would also serve to be a background for the present episode. The various videos I have made so far are Importance of Programming for Electrical Engineers, Computer Programming for Beginners, Fundamental Terms of Computer Programming, Make Research Thrilling, Preliminary Introduction to C Programming Language, Embedded System Learning Strategic Approach, Reading and Writing Skills to Excel in Life, Profession and Research. Those who are viewing this particular episode can refer back to my first episode on Embedded Systems Strategic Approach. So let us begin this present seminar. Now, before we start learning the programming concepts, we need to have certain information about what are the programming prerequisite skills we need. So, to learn any subject, we need to have some inbuilt skills. Let us see what are the various skills required to learn programming. The programming skills are aptitude and technical. As regards aptitude, we have general skills and advanced skills. Now, what are the general skills? You need to have communication skills, both verbal and written. You need to have problem-solving skills because writing a program is an art. You can write a program in various ways using various logics, but writing the best program which will execute in the shortest period of time is an art. So you need to have problem-solving skills. You need to have patience. You need to have the curiosity to do better. You need to have the capability of adaptability. Then accountability. You are accountable for what you have written. You need to also have time management skills. Now, coming to the advanced skills, you need to have reasoning and teamwork skills. Because if you are going into a software job, you will be working in a team. Whether it is a software or any industry you are working, you are always working in a team. So you need to know to have teamwork skills, how to mingle with your colleagues, seniors and juniors. Now, as regards the technical skills, the primary computer skills required are typing. You need to know typing because there are many students who are coming to the doctorate level, but they are not able to type fast. So practice typing. Then computer fundamentals, knowledge of computer fundamentals such as what are the parts of the computer, what is the number system, memory, input, output. All these concepts I have covered in my episodes on computer fundamental and programming introduction. Then you need to have knowledge of Word, Excel, PowerPoint, C++. This is MS Word, Excel, PowerPoint and C++ because all these softwares are required. Now, this is apart from the software where you need to execute the program. Say you are having your running an 8086 microprocessor program. You need to have the software related to 8086. Apart from that, you need to know these softwares. Now, advanced computer skills are Java, databases, front-end, back-end, SQL, HTML, MATLAB, Python. And must know knowledge about the subject area for which you want to develop the embedded system. You should have an awareness of that subject area, the hardware and software requirement. For example, you want to develop an embedded system for motor control, then you should know what parameters influence the performance of a motor as speed, torque, voltage, etc. Now, if students are saying, you may please keep a notebook, pen and dictionary near you so you can prepare your notes well. Now, so first we need to have the knowledge of chip architecture, which I have explained in my previous episode. That is size and name of the primary registers. Registers are small memories. So, for example, in 8086, you have the 16-bit AX, BX, CX and DX register. So, whichever chip you are using, you should know what are the primary registers so that you can write your program well. Then, the registers, additional registers as stack, process status word, timer, counter registers, serial communication registers, and any other aspect related to that particular chip. Now, you need to know what is the program structure, how to write the program. Then we need to know what are the various instruction sets and what is the syntax for the instruction. What are the various data types and type of instructions. What are the various types of instructions supported by the software related to that chip. That is arithmetic instructions, logical, loop, relational, data transfer and jump instructions. Then you need to know which program editor you will be using, how to write the program, compile the program and execute the program. Then you also need to know how to debug the program. That is, if there are any errors, how to eliminate the errors. Now, whenever you are typing a program and compiling and you're getting errors, you please make a note of all the errors you are getting and how you have rectified, because these are the points that will be asked in your competitive exam and interviews. Like say, if you're getting this particular error, what does it mean? And how you will eliminate that error. These are the questions that they will be asking in your competitive exams and interviews. Now, as I said, you need to have an idea of the number system and Boolean algebra. That is decimal number system, octal number system, hexadecimal number system, and the various conversions. That is how to convert decimal to octal and hexadecimal, then how to, and vice versa. Then you need to have knowledge of Boolean algebra. What are the various logic gates, their operation, their principles and laws. Now, this is the 8086 architecture, which I had already presented in my previous episode. But for easy reference, I have placed it in this particular episode also. The two important components of 8086 are bus interface unit and execution unit. Similarly, we have 8051 microcontroller architectural diagram with the various components, which we had already discussed in our previous episode. Now, what are the important features of 8086 microprocessor and 8051 microcontroller? We'll just have a look. 8086, it is a 16-bit architecture. It has 16-bit data bus and 20-bit address bus. As I've already mentioned, every chip will have 3 buses, data bus, address bus and control bus. We need to know what is the size of these buses because we will know how to handle the data. Then the address and data buses are multiplex. That is, some of the pins are used both for address and data. Why? Because at the same time, we will not be transmitting data and address on a particular line. Then 8086 has 1 MB memory. It has a 6-byte queue to increase the speed of instruction or execution. So that is, the instruction is fetched and kept ready in advance so that it is easy to execute. It has 2 main units, bus interface unit BIU and execution unit EU. It operates in 2 modes, minimum and maximum. It has 2-stage pipelining, fetch and execute. This is to increase the speed of operation. Coming to 8051 microcontroller, it is an 8-bit controller. So it has an 8-bit CPU. It has an on-chip clock oscillator. It has 4K bytes of internal ROM, 128 bytes of internal data memory, that is RAM, 64K bytes of external programming memory, 64K bytes of external data memory. So data and programs are separated. Has 4 ports, each of 8 bits. So 8 4s are 32 pins we are having. So if you say you want to connect LEDs, you can connect 32 LEDs at a time. It has two 16-bit timer and counters, T0 and T1. That is, you can use as a timer or a counter by setting the right mode. It has 4 register banks with 8 registers in each bank. The 4 banks are named B0, B1, B2, B3. It has a 16-bit program counter and a data pointer. It has 8-bit program status word and 8-bit stack pointer. It has a 5-vector interrupt structure, and it has an 8-bit arithmetic logical unit ALU with associate registers like accumulator, A, B, other registers such as PSW, stack pointer, and program counter. Now, 8086, the various registers of 8086 are categorized into 4. General purpose registers, pointer index registers, special purpose registers, and segment registers. Now, what are the general purpose registers? Here in 8086, as it is 16-bit microprocessor, the AX, BX, CX, DX. We can use even 8-bit. That is, the lower 8 bits are called AL and the higher are called AH. So also we have BL, BH, CL, CH, DL, and normally all the final results are stored in the accumulator from which you can transfer to your memory. B stands for base index. C register is used normally as a counter, and D is for data pointer. So we have the pointer index registers as stack pointer, base pointer, source index, and destination index. Other special purpose registers are instruction pointer and various types of status flags. The segment registers are code segment, data segment, stack segment, and extra segment. The 8086 program has 4 segments. Now, coming to 8051 registers, they are classified into port registers, timer registers, interrupt registers, serial port registers, pointer registers, and others. Now, the port registers, as it has 4 ports, P0, P1, P2, P3. So, they are addressed as P1, P0, P1, P2, P3. Now, coming to the timer registers, you have TL0, TH0. That is timer 0, lower order bits and higher order bits. Similarly, timer 1, lower order bits and higher order bits. And to know the mode of operation, we have TMOD and control TCON. Then interrupt register, IE and IP, interrupt enable and pointers. Serial port registers, SBUF and SCON. Pointer registers are IE and IP also. Then other registers are general purpose registers AB, and we have registers R0 to R7. You have process status word. You have process status word and then PCON. R0, there are only 8 registers, so R0 to R7. The other special function registers, see, as I already mentioned, SBUF, TMOD, PCON, IE, TCON, SCON, and interrupt priority. Now, the 8086, we need to know the program status word. Any chip you are learning, you should know what is the program status word, what is the size of this word, and what are the various bits. So what is the status of execution of the instruction? We will know from this program status word. 8086, it is a 16-bit registers. You can see only some of the registers bits are used, while the other bits are used reserved for future use, which are put as cross. So here we have CF, that is a carry flag, that is carry out of the most significant bit, then this is set to 1. If there is no carry, it is 0. Parity flag, 1 is even parity, 0 is odd parity. Auxiliary carry flag, 1 carry from lower nibble to the higher nibble, 0 if there is no such carry. 0 flag, if the result of the previous instruction execution is 0, it is set to 1, otherwise it is set to 0. Sign flag, 1 if the MSB of the result is 1, or 0 if the MSB of the result is 0, that it is a positive number. Used for signed numbers. Then you have trap flag, that is perform single stepping and do not perform single stepping. Then you have interrupt flag, enable interrupt, disable interrupt. DF, that is direction flag, auto decrement, auto increment. Then you have overflow flag. Overflow, if it occurs, you have 1, otherwise it is set to 0. So these are the various bits that are set whenever an instruction is executed. Similarly, we have 8051 program status word, which is 8-bit D0 to D7. Here you have carry flag, then D3 to D4 when there is a carry from D3 to D4 AC, F0 for future use, not use as of now, OV, overflow flag, parity flag, RSO and RS1. That is, since we have the 4 register bank, by setting this RS1 and RS0, we can know which register bank you have selected. That is 00, you have selected bank 1, 0, that is B0, 01, bank 1, 10, bank 2, 11, bank 3. Now, what are the rules of assembly language? The assembly code must be written in uppercase letters only. Then the labels must be followed by a semicolon. All symbols and labels must begin with a letter, and all comments are typed in lowercase. The last line of the program must be the end directive. The assembly language mnemonics are in the form of the opcodes such as move, add, jump, and so on, which are used to perform the operations. To know what the various operations are supported by the particular chip, we need to refer the respective manual of the chip. Now, what are the elements of assembly language programming? That is, assembler directives. It gives the direction. It gives a direction to the CPU. This assembler directive. The directives are, say, like ORG, origin, define byte. You specify what type of data it is, EQU, equating, and end. That is end of the program. So instruction set, you need to know the instruction set. So you have to refer to the manual of that particular chip. Addressing modes. What are the various addressing modes supported by the chip? Say immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and base index addressing mode. These are the various addressing modes available. So we should know how to use this. What is the syntax of using these modes? Now, we'll see some of the directives of 8086. EQU. EQU is, it assigns the value of an expression to the name specified in the label. Syntax is label, mnemonic, operand. That is label. The label I've given here is once, EQU, FFH. That is once has the value FFH. Set. Set assigns the value of expression to the name specified in the label. That is mark set 05H. So I have made the marks 0, 5. So whenever I access marks, I'll be getting the value 0, 5. Data definition. That is, what are the various data types supported by that particular chip? Defined byte, defined word, then example, string, this is the label, str, defined by type. So I'm defining this variable to this data type, db. Greek, defined by 034h. Word, once. Word, another data word, defined word, dw is geek. And then you have another label, defined word a, comma, ab. End directive. The end directive identifies the end of the source program and terminates each pass of the assembler. Now we have another called as location counter control directive. That is the ORG directive. The ORG directive tells the assembler where to load the instructions and the data into the memory. So normally the first line in our program would be ORG. In ORG, you mention where you want to store your program in the memory. It changes the program counter to the value specified by the expression in the operand field. Now, 8086 instruction set. It supports 8 types of instructions. Data transfer instruction, that is to transfer data from one location to another. Operations, bit manipulation instructions, then string process control instructions, iteration control instruction, and interrupt instructions. So first we make a list of all the types of instructions supported by that particular chip. Then we will go into details of each type of instruction. Now, the syntax. We need to know the syntax of the instruction. So whether it is 8086 or 8051, the syntax of the instruction is label, then operator or mnemonic, followed by the operands. And comment statements are preceded by the semicolon. Brackets indicate field is optional. That is, whatever you're putting in the brackets, it's an option. You may have a label or may not have a label. Then brackets should not be typed. The label field allows the program to refer to a line of code by the name. So this line of code, whatever you're writing, whatever name you have given here, you will be referring to. For example, here I'm referring to this name with geek. And here I'm referring to this particular instruction as ADDR1. So if I say ADDR1, it means DW once. Operator is an operation to be performed on the operand by the instruction. And every assembly language has its own sort of operators as arithmetic, logical. Some of the operators we have already seen. The comment field begins with a semicolon. So this is the syntax of the instruction. Only if you know the syntax, you can write the program. So we will just see what is the program structure of 8086. Initially, we give the comment statements. In this comment statement, we will be writing what is the name of the program, the date of the program, who has written the program, and why this program was written. Then you have what is called as a data segment, wherein you declare your variables, and then you end your data segment, data ends. Then code segment begins. Here compulsory you need to write assume CS code, DS data, and then you start your code segment writing the instructions. So here I'm written the 2 small instructions, move AX data. That is, I'm moving the data into the auxiliary register AX. And then into DS, I'm moving the contents of EX. Similarly, you can, based on your logic, you add some more instructions and then you end your code. After ending the code, you need to write and start. Right? So here we will see the 4 assembly segment registers of 8086. Right? As I have said, it has 4 registers: extra segment, code segment, stack segment, and data segment. Now, the segment registers hold the upper 16 bits of the starting address of the 4 memory segments that 8086 is working with at any particular time. So here we have the data segment. The data segment starts from this particular address to this address. So this is the range of or the memory location where the code segment is stored. So this is the bottom of the stack segment. This is the top of the stack segment. Similarly, this is the bottom of the extra segment. This is the top of the extra segment. And this is the highest memory location of this is the physical address, highest physical address of the segments. Now, coming to 8051 programming structure, it is simpler compared to 8086. You just have to start at the origin 000H. That is, you're starting at 0H. You write your instructions and then end the program. For example, program to add two numbers. This is the comment statement. So it begins with a semicolon. Start 00H. Move A hash 25H. That is the first number and storing in the register A. Let us load absolute value 25H into A. Then move R3 35H. That is R3. You can use any one of these registers R0 to R7 instead of R3. Add A R3. That is add A R3. The first number 25H is already there in the register A. So by adding R3 to A, we get the resultant of 25H plus 35H. The resultant is stored in the register A. Now we will see an application of 8051. That is a program for blinking of LED using 8051 microcontroller. In the diagram, we can see that the microcontroller has 4 ports, P0, P1, P2, P3. Each port has 8 pins. We can use this port as the entire port with 8 pins, or we can use each pin at a time. So each pin is addressed as, say, the port 0, P0 dot 0 or P0 dot 1. So we will just see the application wherein we have connected a LED to P1 dot 0 and we want this LED to glow for some time and then be off for some time. So the code is ORG00H. Toggle, it is the label for this instruction. Move P1 hash 01H. So move 000 0 0 0 0 1. So LED is put on by setting it to 1 and put off by setting it to 0. So once we have moved this 01H into P1, this LED will glow. Then we call a delay because we want the LED to glow for some time. Then we have to move the contents of P1 to the accumulator A. Then when we complement CMPL-A, all the zeros of 01H will become 1 and what was 0, 1 will become 0. So that means the LED will be off. So we move this content of A to P1. So when you move the contents of A to P1, the LED will be off. When the LED is off, again we call the delay subroutine. So in this way, we can loop this for as long as we want. Now we have to write the delay subroutine. So the delay subroutine is delay move R3 hash 255. So we have moved the number absolute value 255 to R3. We keep decrementing this R3. So loop 1 DJ and J decrement and jump if not 0 R3 to loop 1. That means if 255 is reduced by 1, it becomes 254. 254 is not 0. So the control stays in this particular instruction only. So this instruction continues as long as this R3 becomes 0. When R3 becomes 0, the control goes back to the main program. Now we have a software paradigm. Programming is an art. There are many ways of writing a program, but the code that has the least number of lines, executes fast and takes the shortest resource time is the best. So when we are doing program, we should keep this in mind. So thank you. If you have any queries, you can contact me on my mail ID.